Hi there, John Bruggeman here, consulting CISO for CBTS. We're here at RSA for an Inside the CISO's Office RSA edition. I'm here with Niall Browne with Palo Alto. You're the CISO, so tell me a little bit about what you're doing.
Yeah, I am indeed, John. And first of all, thanks for the opportunity to chat back and forward. So my role in Palo Alto Networks is responsible for cybersecurity within the company. So how do we protect basically our data, our tools, and our customers?
That's a big job.
It is certainly, and certainly when you look at the threat landscape that's out there, it gets more and more interesting kind of every single day.
That is the nicest way to describe it, when you are probably a very big target for a lot of cyber actors who want to get behind the Palo Alto firewalls that are out there. Not that that's all that you do, but go on.
Yeah, and the good thing is, I mean, it's fascinating. You get to see what's happening across the industry. You get to talk to a multitude of customers. You get to see how the products can tie into a point solution, can tie into a platform from there. So for me, certainly it's one of the very few kind of unique opportunities whereby you get to see a significant portion of what happens out there, and then you get to help customers on a daily basis on how do they protect their technology, their industry, their data, and their people as well.
Yeah, because Palo Alto has a pretty broad portfolio of solution offerings. And one of the things that's getting a lot of talk still in the industry is zero trust. So I've given a couple talks over the last 18 months. And when I ask people in the audience, how far along are you on your zero trust journey? Typically less than 10% of the audience has even started it. So when you think about zero trust, what are the things that come to your mind as the CISO for Palo Alto?
Yeah, no, great question. I mean, if you look at the pivot from years ago, was you did a perimeter security, the hard shell.
Yes, very hard shell.
Yeah, but once you're in the hard shell, you're in sort of thing, and you can access everything from there. So simple example whereby you would authenticate and your session might be valid for a day or 2 or 3 days. Anybody who can steal your session token itself or steal your identity is in that environment for 2 or 3 days. And then they assume other identities, they move laterally from there, and it's nirvana. It's very, very simple and very straightforward to do.
Nice flat network. There's no segmentation. Those were the good old days.
That was a very monolithic in itself. And now what's happening is basically people realizing maybe that's not the best solution in itself. So like when John acts to that environment, wouldn't it be great to know like who you are? Mm-hmm. Wouldn't it be great to know like what device you're on? Wouldn't it be great to know what application you're going to, and then to validate every single connection going back and forward? And for me, that's really the definition of zero trust itself. I want to know everything about every single connection coming in and out of Palo Alto Networks so that I can secure that at any point in time. And suddenly, if John starts logging in from France, or you start accessing systems you typically don't access, or you access an application whereby there's some unusual behavior,
or you suddenly have super user capability,
then the system should be able to look at you and say, well, maybe we shouldn't allow John in there anymore. Maybe we should remove his access from there and really...
Or make him re-authenticate at least.
Exactly. And that's really what zero trust is about. And I think what, when you mentioned the start basically, a significant portion of people are struggling with this. It's the model whereby it's like asking people like, how long is a piece of string? Like it's very nebulous in itself.
Yes.
And people will often look at this and say, well, for zero trust, like, where do I start it?
Where do I start is a big question I get a lot.
And then often the people say, well, you got to protect everything. Well, no, that's not the right answer, because like you don't want to protect your canteen menu at the same level as your crown jewels, your sensitive data. So what I've often seen organizations do and say, listen, it's like a sprint versus basically a marathon. Basically, a marathon will go on for ages and ages. A sprint, you want quick wins from there, because you need to bring the stakeholders, the CIO, the board along with you. So what I often do as part of this model is I look across all of my crown jewels and I pick the one, what's the one out there that's the most sensitive? Like what's the one that I need to protect the most? And in our case, it could be source code in a financial institution. It could be basically financial data, medical, healthcare data. And then I look for basically, let's go on a journey protecting that every single step along the way. I want to know where that data is, how it's protected, and I want to apply zero trust to that.
And who's accessing it, and make sure, when I've talked about zero trust with, in the talks that I give, we start with identity.
Yeah.
Who is the person? Are we sure it's them? Have their credentials been compromised, maybe accidentally or maybe exposed by a third-party data breach? And, putting in a second factor to prove that they are who they say they are. So there's opportunities there for you to do the same thing with that idea. Let's take the crown jewels and move backwards from there.
Exactly. And then it's like, is John the right person from there? Enabling MFA, maybe your session token is three days. It's probably too long. Maybe we want to bring it down to 3 hours from there. Maybe we want to do real-time monitoring of that end. And then on top of that, John might have worked in the company for 20 years. Well, during that time, you've assumed a lot of privileges from there. And the vast majority of those you don't need. 85% typically of privileges you don't need. So like going back to the zero trust on source code or financial data, it's taking a look at, show me and simple steps. Show me everybody who accessed those crown jewels in the last, who didn't access in the last 360 days. Gone. You kill it.
Interesting.
270, 190, 90, 45. You keep on working way back, so you're back to that scalpel model. So only the core people that need access get access from there. So now the nice thing about this is we're not just securing your identity, but to your point, basically, we're securing the identity of every user or service account that's accessing that data. Take that, package that up, put that in a zero trust, present that to the board. Now it's a win. Right. Now you can talk to your CTO, CIO, CEO, board of directors and say, by the way, for zero trust, we apply a zero trust methodology in this company. We've applied it to our top crown jewels over the last 6 months, and here's the result. Now it's quantifiable. Now the CISO basically you can look at the CISO and say, well, you actually achieved something on the zero trust journey.
Yeah.
Now,
you did it in 6 months.
You didn't, and you didn't protect everything, but we didn't expect you. You showed them, demonstrate. Now your team is much happier because now they're bought into that zero trust journey.
Right.
So
they can see the value right away.
Yeah. So I think wins whereby it's the most sensitive data, it's time-based, it's results-orientated, it's huge. And then at the end of the day, someone wants to access that data, now it's exponentially more secure. And along the way, you've taken 2 steps forward, 3 steps back, and you've realized the mistakes you've made. Now you move on to the next crown jewel, and you get better, and you get better, and you get better, and you'll never protect everything. But if you can protect like the most sensitive crown jewels using a zero trust methodology, you're golden. And the problem is, as you pointed out, is because of the issue that people aren't willing to start the journey because they don't know what's that first step, never mind what the end is from there.
Yeah, they people do get a little paralyzed by the potential size of the problem, and they choose the path of, well, we haven't been attacked at this point, so it's probably not a problem. We don't probably have to do zero trust, and that's the wrong idea. That's the wrong takeaway from a conversation about zero trust. So when you think about third-party risk management, what are the things that you consider?
Yeah, and that's the big thing, because generally, if you think you're in control, then you're wrong, because you're never in control. Because for the most part, if you look at any company, generally they don't own the building itself, and they have management and they have maintenance from there. The software stack that they run on, maybe even if they're a software development code, maybe 10% of the code that they write is theirs. 85% is somebody else. So when you look at that, it's a huge interconnectivity of basically third-party vendors and supply chain. So let's maybe take third party. Most large organizations will have maybe 5, 6, 7,000 vendors. Now, the good thing about this is some of them are selling plants. So you don't really particularly care about those.
Right.
Ben, going back to your example about crown jewels, we're looking at basically at third-party risk and show me the top tier ones that have access to crown jewels, and that's the ones you apply the highest rigor. So starting off with questionnaires, audits, and assessments, looking at their security score, looking at their attack surface risk from that end, doing an on-site assessment if you need to from there, and then following up step by step, making sure you've got the right legal contracts in play.
Yeah.
And then really kind of working with them kind of step by step on the journey. And the problem is at scale, because even if you get down from 5,000 down to 600, now
600 critical vendors that you have to deal with.
Then that's an issue, because now you got to chase down 600. So what often happens is, I think, is the CIO and chief financial officer is the best partners for security. Because,
for that part, because it's risk.
Yeah.
They're talking about risk.
Yeah. And it's consolidation. It's risk and cost. Yeah. So CIO is I don't want to be supporting thousands of vendors that do the same thing. So everybody in a company, for the most part, is a vested interest in consolidate the amount of vendors, especially those that have access to crown jewels, then secure that to the end degree from that end, and then you move on to the next one. Then you do a continuous monitoring model from there. So third-party risk is key, and especially it's you approve them, and then then it gets interesting. It's what kind of access do they have? What's that service account going back to your maintenance and HI? Can they dial in? Like, how does that work end to end? And it's really having within third-party risk management, basically having technical people that can look at the integrations and say, yeah, that's a secure integration or not. Otherwise, what happens is, you get a service account that's valid in perpetuity, and they can access it whenever they want, and they have access to everything within that infrastructure. So, for us, that's always key. Third-party risk, where there are vendors like SaaS, and then the second one, to your point, is like supply chain.
Yes,
and that's huge. So, that's whereby you look at your tech stack and you realize, by the way, I don't own a lot of it. And if you don't own a lot of it, basically, how do you secure it every single step along the way? And a lot of organizations, when they look at it, is that they'll, for the most, they'll run on, they might run Apache, they might run Ubuntu, they'll run on, and somebody else created that, not them, from their third-party libraries and source code.
Oh, that's huge.
And oftentimes when organizations look at it, they often may find 20, 30, 40, 50, 60, 70,000 individual third-party libraries that are out there.
That was going to be my follow-up question. So I'm thinking of a company like Palo Alto, where obviously you're developing code.
Yes.
And you want to look through the code that you're developing. I mean, unless you're writing your own, ground up operating system, and you probably are doing that, but it might require some software libraries. If you find a vulnerability that has, a software library that has a vulnerability that's 3 years old, do you decide that you're going to rewrite that library and get it out of your technology stack, or do you do something different?
Yeah, I mean, our core focus then is you don't want to obviously have any vulnerabilities running in your current environment. So then it comes back to choice. So, you go back to the engineer, because security should never make the decision and say, we're just going to kill that.
That doesn't go over well.
It doesn't. Instead, it's like here's what the issue is basically. It's a CVE of, let's say, 7 or 8 from there. It's a big issue from that end. What is there an alternative we can do? And if there's an alternative, when can we do the migration? Because in some cases, if you look at Log4j, even in those cases, even when the whole company's working, it can take them days and weeks to work it through that system, because it has a critical business function and impact.
Right.
So I think
you can't just rip it out if it's in production.
Yeah, and if you do, you kind of bring down the whole system, which is like you're the core issue from there. So oftentimes, basically, it's you look through the packages, which ones are insecure. First of all, which ones, like a lot of times you'll see binaries in tech companies, they aren't being used. Like they've just been called over time. So you can get rid of those. And then what's the ones that most of the customers I work with, I say, well, are you running software that's 20 years old? And they're like, I think we are, sort of thing. Get rid of that, and then you make it easier. So in other words, you shrink the attack surface from there, and then after that you can focus on, here's the core set of basically libraries, whereby you're looking at basically, can I switch one for another itself?
So you might have two libraries that do similar enough things. Yeah. This one's well patched, this one not so much. Yeah. We're going to make the shift.
Yeah, and oftentimes you'll find there's the right choice whereby engineering would look at it and say, yeah, that makes sense actually to do that. Every single tech company in the world is starting on that journey. We've heard about supply chain. People are like, well, that's yesterday's news. That's a year old. We're seeing in supply chain, this is going to be a 10, 15-year conversation.
It's a journey.
Yeah, and it's a huge journey from there. And the good thing is that people are starting to fundamentally make the right choices. Like the first thing you want to do is visibility. They're starting to build the visibility in, and then you build the logic in, and then eventually you can build in the prevention kind of component of that. Mm-hmm. And then the nice thing about this is, finding something that's already shipped, no good. Like shift right doesn't work if you're doing that solely, because you can't convince the engineers to fix it. If you can I fundamentally believe if you can get as close as possible to the developer on shift left close to the developer, you can achieve phenomenal results from there. Because now you can scan secrets, you can scan infrastructure, you can scan for all these certainly bad things before, not always, but before they're introduced into production.
So is that done with a training and awareness for the software developers, or is it a strategic decision to say, look, all right, we've got our development team, we're going to sort of insert a security person who's a part of that team meeting? I mean, I can imagine two answers to how that can happen.
Yeah, I mean, here's the way it's numerous different ways. I mean, the one I find works really well is offer as a service. So it's like to say, first service that you could have is you've got, let's just say we talk about software security, and software sits on containers. And then if it sits on containers, and containers are pulling from old images, or you're pulling from 200 images, then you're going to have a huge amount of issues shift right. So oftentimes security, what I see works really well is spin up a service. I'm going to call my service container security. And then container security is going to be defined by a set of like 10 or 15 principles. You know, we will make simple stuff. It's like we will work with engineers on designing on what images should be supported. Generally, there's 10, 15. Security will be responsible like for keeping them up to date. We'll put them in a shared location where they can be accessed.
So it's a shared responsibility.
And then you sit down with them on the service side, and then you start onboarding them. And generally, the way it works from there is like, you know, it's like, hey, engineer, you're 95, you're 100% in control, because they should be, because they know their environment exponentially better than me or anybody else. And then it's the case of like, you do the integration. Now you can see what the issues are. You can see the vulnerabilities that are happening here. And then you can draw insights. And the insights could be, well, you're running 200 images. If you're running 200 images, basically, and I've seen this across hundreds of customer environments, basically, whereby when I speak to them, it's like, yeah, we're running about this amount of images. They can't manage that.
No, that's an unmanageable number.
So then it's like going down to golden images. Do you want to create them, or we create them from there? Then they pull the golden images. And then on integration, it just checks to say, are you pulling basically the latest version of the software, and are you shipping that into container infrastructure? If you are, golden. Now, the thing is, you don't want to break the build.
No.
Because if you break the build, A, you're going to break the business, and B, you're going to be called up at 3 o'clock every single night.
Yeah.
So instead, it's the first step is integration, done. We call it level 1. Once you've done the integration, next step after that then is visibility. Now you get visibility, and like, now I can see the results, and you as the engineering leader can see the results. And now you're saying, well, we're shipping quite a few vulnerabilities in there. We should probably go fix that.
Right.
And then it's like, here's a solution. Well, here's the solution on the images, golden images. And then after that, then it's a case of working with them on, can we work on an SLA to go fix it within a certain period of time? And then
2 weeks, 4 weeks, whatever.
Exactly. And eventually it's you get to the point whereby, and generally it's like 4 or 6 months in the journey whereby it's like the engineering says, yeah, let's do a break build. And then now you've offered your service, you build a partnership, you build trust. They want to do the break to build, and you say, well, let's do break build, but let's do break glass, because I'm never 100% right, and neither are you. So there's going to be false positives, and you don't want to be called at 3 o'clock in the morning. So it's break the build, and then anybody in engineering, as a manager above, can basically break the glass. And if they break the glass, they can still ship it. And then the nice thing about that then is you got all the metrics in the world. You know, it's like we broke build 5 times, but you broke glass 50 times. And the reason you broke glass 50 times is because maybe our model was wrong at the start. And then you iterate on that. But it's very much a case of like building a service, making it shared, defining a simple like set of principles and erasing it at the start, and then working with them product by product by product by product. And
once again, a journey.
It's a journey sort of thing, but you can make significant kind of inroads there as well. Because once you do, the good thing is once you do one and you've learned like what works and what doesn't work, so you've learned from your mistakes, then the next one is much easier. And then if you can do a second one, maybe you can do 2 in a row, and then you create 2 tiger teams to create 2 in a row. Then you create 3 tiger teams. Now you're doing 3 products in a row in the integration, or 4 from that end. And then very quickly you can get through, like in most organizations, they may have like dozens of products. Securing one is good as a proof of concept, but now they can move very, very quickly. So that's where the model of like, scalability comes into as a service, building tiger teams, doing it in parallel, and then the next one. And with any service, it's like, it's like if someone's on a bus, it's good to know that they're actually on the bus. The same thing with a service is like, it's good for them to know they're on the service. So the way we certainly did it internally, basically, is we would sit down with the products leads and would say, listen, do you want to sign up for the service? And generally they were like, or you can go build it yourself. Well, no, we'd like you to build it from there. So that's done. And then we say, right, we want skin in the game on this one is you've got to kick in half an FTE towards us to do this.
Okay.
So the nice thing about that model is they're kicking in half an FTE to help us going through the process. So now we're teaching them how to fish, going back to your example of the shared responsibility, which is really good because now they can do a lot of the security work for us because they know the business exponentially better than us. And
they certainly know their product. Yeah,
exactly. And then what we'll say is like when we onboard, example of products in the past were singular and monolithic, then it became microservices. And if a microservice is 50 microservices, you might have 50 software pipelines. You don't want, from a security point of view, going back to you have to onboard dozens and dozens of applications. You don't want to onboard basically every single pipeline because you're going to be there all day.
Right.
So in our case, we did a model is we would onboard them for the first 2 pipelines and teach them how to do it. And then their security warrior on their side, which is half an FD, would onboard the other 48 over time. So again, it's kind of the model of like, almost like industrial engineering of like, it's easy to fix something when it's one, fix something when it's hundreds of thousands, it's exponentially. So it's kind of, how can I scale with the engineering? Because the problem is when engineering, once they realize you can't scale, they won't want to work with you. It's like, by the way, I said, John, can we have a meeting? And they're like,
can we have a little meeting?
Can we have a meeting? Engineers don't want to meet cybersecurity in any shape or form itself. So if you can kind of processize it in some way, and I'm a huge fan of creating like sets of principles, create a simple RACI from there, and then work closely with like the SREs for integrations, you can achieve, I firmly believe you can achieve a huge amount. Compared to like a year ago, people were like, supply chain, I don't even know what that is. So again,
I think of it in the context of I'm not getting hardware shipped right now because it's 2021 and my supply chain is broke. But yeah, there's definitely the software supply chain. And just two things for clarification, because I'm sure some people are not as familiar with a break build or break glass. So just a couple seconds on what those two are from the context of software development.
Perfect, excellent. And the great thing is most of this will tie into like, nomenclature for engineering. It's like, break build is whereby, imagine if you're shipping a performance vulnerability. And then if the performance vulnerability doesn't meet, if it's a significant risk from there, then it's you break build. So they can commit to production until they actually fix it.
Now, so the breaking part is typical build process would be the developers develop it, it goes into testing, problem is found, it doesn't go into production because you're breaking the build because the problem is a security vulnerability, so you send it back.
Exactly, yeah. And the model there, and it works very well for engineerings and other sides of the business, so which is good. And then the second thing about that is when they look at like the break build, it's not as if someone writes code and it ships into production like 2 minutes later. Like most of the code,
we do have a separation of duty between test to production.
And it can take days or weeks to work through. So if they break build at the early stage, it doesn't make a difference. And then the break glass model is whereby you don't want them to come back to security and say, oh, by the way, security, your tool failed. Or basically, when you scan for a secret, you scan the wrong basic format from there because break stress. Much more simpler whereby they have the ability to break glass. In other words, they've got the ability to override and ship it if need be from there.
Interesting.
Now that gives the engineering key power from there. So then you work closely with them on like, why did you do that? What was the reason to do that? But firmly believe like if you're going to break a build, there's got to be some capacity basically to break the glass on their side.
And say, all right, I know you don't want us to put this into production, but I'm going to break glass and we're going to go ahead and push it into production.
Yeah, and generally when that happens, basically, it's an error on security tooling, not on the engineering side. So the engineering would look at that and say, yeah, your engineering tools is broken in some way, so therefore we'll do a break glass from there.
Yeah. And then you get metrics on that.
You got the metrics itself, and then it's like you make sure your tools and technologies, because even no matter what you do and you build, because there's so many different code bases and images from there, you're going to have false positives, and so this is a great way to work with them on the false positives.
Yeah, because it could look like a security vulnerability, but it's not.
Yeah.
In which case, you don't want to break the build and then they have to go back and go, we told you this wasn't really a vulnerability. And the security guy goes, well, it came up as a vulnerability. Yeah, that's a problem.
Because otherwise what would happen is you'd have to have security team members on call 24/7 all around the world that know every single product.
Yeah, and not going to happen.
Again, going back to industrial engineering and scaling, it's just going to fail on its first steps.
Gotcha. So that is a great point. We're going to use this as a way to wrap up our meeting, and I'll leave it up to a further conversation at another time about artificial intelligence.
Perfect. Awesome. That's great.
Great.
Thanks, John. Cheers.